2x2 table and cross-tabulation. Have you had to interpret a 2x2 table? 2x2 tables are often used in clinical trials to evaluate the association between a possible risk factor, for example, exposure and the outcome of a disease. By using this table, you can calculate the absolute risk and the odds. It's also possible to determine the relative risk and odds ratio, which we'll show you in the next steps. First, let's take a look at the origin of the name 2x2 table. If you've watched our previous episodes on statistics, then you're already familiar with our fictional study investigating 100 smokers and 100 non-smokers. In the smokers group, 20 developed lung cancer, and the remaining 80 smokers were unaffected. In the non-smokers group, 2 developed lung cancer and 98 remained unaffected. The results of the study can be presented in a table with 4 fields, so you can see where the 2x2 table has its name. It's also called a contingency table. The total can be generated from the 4 fields. The total number of smokers and non-smokers included in the study are listed on the right, whereas the total number of individuals with the disease are on the bottom left. The total number of study participants with lung cancer is 22. In the bottom right, you can also see how many individuals didn't develop lung cancer, which is 178. So, how do we calculate the absolute risk and odds from this table? To determine what the absolute risk and odds are that smokers develop lung cancer, the only important numbers are those in the upper row. So you can see that there aren't many possibilities to calculate these values. Let's start with the absolute risk. The absolute risk of a smoker developing lung cancer can be calculated by dividing the number of individuals with the disease by the total number of individuals. So, 20 divided by 100. The odds is calculated by dividing the number of individuals with the disease by the number of individuals without the disease, which is 20 divided by 80. We can, of course, apply this to the row of non-smokers and also determine the absolute risk and odds values. In an additional step, the relative risk and odds ratio can be calculated. For our example, the odds ratio is calculated as the odds of smokers divided by the odds of non-smokers. That's 20 to 80 divided by 2 to 98, which gives us 12.25. There's another way of determining the odds ratio, which we'll now explore in further detail. Let's focus on the middle section, in which we compare the odds of both groups. It can also be represented as a fraction, 20 to 80 divided by 2 to 98. Now, we can apply the following simple algorithm. Dividing the first fraction by the second fraction is the same as multiplying the first fraction by the reciprocal of the second fraction. So, we divide 20 by 80, which is then multiplied by 98 to 2. The odds ratio is usually calculated using this method, as the values are easily accessible using the 2x2 table. Let's highlight this in the table. We multiply 20 by 98 and divide it by the product of 80 and 2. As you can see, you can also calculate the odds ratio by multiplying the opposite values with one another, followed by dividing them. So you're calculating in a crosswise manner, which is why it's also called cross-tabulation. In short, cross-tab. Through cross-tabulation, we end up getting the same result, namely an odds ratio of 12.25. The letters A to D are commonly used to label the 4 cells in the table when performing calculations and to derive formulas. Let's use them in our example of the odds ratio. We could also write down the calculation of the odds of smokers as A to B and of the non-smokers as C to D. The formula for the odds ratio would then be A to B divided by C to D. This corresponds to the crosstab A to B multiplied by D to C. It's important to us that you don't just memorize these formulas, but understand what you're calculating by being able to derive them on your own. For example, imagine that you've learned the formula for calculating the absolute risk, A divided by A plus B, or 20 divided by 100, which equals 20%. As is sometimes the case, A problem arises with a 2 by 2 table if it's inverted. The axes are now reversed. The smokers and non-smokers are at the top, and individuals with and without the disease are on the left of the table. If you now use the same formula to calculate the absolute risk, A divided by A plus B, or 20 divided by 20 plus 2, we would obtain a value of approximately 90%, which is incorrect. So we recommend that you don't just memorize these formulas, but develop an understanding of the individual measures that can be used to calculate these values.